as an essential element and a foundation for security, which the Orange Book did not do. The Orange Book did not directly do it. Okay, it did not rule out the use of cryptographic techniques, but it didn't use cryptography as a foundational element, and providing protocols to establish trust within a platform. So it's not only enough to secure your keys so that they cannot be accessed in clear text by malicious software. You also need to make sure that they are usable only by approved software. And that's a very important insight, that, okay, you can protect the keys, but if the keys can be used in the protected container by improper software, then the malicious software can use your keys. So just protecting the clear text key is not enough. You have to protect who uses the key. And the TPM provides mechanisms for ensuring that the key is used only by an approved application. And it does that by computing hash chains and stuff like that. And I'm not going to get into the details of the trusted computing aspects because those are well known and well published. You can certainly look at Trusted Computing Group and you'll get tons of literature on how they're doing this. It's a standard. There's nothing hidden about it. And I will point this out, that in the Orange Book philosophy, the whole idea is to eliminate trust from the application, do everything in the kernel of the operating system, no need to trust any application. And, that idea didn't fly. And I believe it didn't fly because fundamentally you cannot escape from putting trust in the application. It's just a silly thing to be even trying to do, because the application is the only one who really knows what it is that is being protected. And you cannot protect it only at the level of bits and bytes. You have to protect things at sort of the layer of abstraction that only applications can provide you. Okay, so I believe it was a fundamentally mistaken approach, and modern trusted computing goes completely to the other direction and says our real problem is to sort of make sure that only trusted applications can get the keys which enable access to content. Okay, that's really the essence of this approach. By making sure that only approved applications can access the content, you are then relying on the application not to do leakage of data. And you want to make sure that the application can run confined so that other software on the machine which is simultaneously running, concurrently running, cannot grab that data. And that you do by increasing the strength and quality of your memory protection. So again, all of this is, there's nothing that we have contributed here. This technology has come out of Intel, HP, IBM, Microsoft, etc. So the question for us is how do we use this? And basically that's the project that we've been working on. It's funded by Intel, so you can appreciate that they have some interest in this technology. So what is information sharing? Again, described very quickly, it's share but protect. And fundamentally, it requires some controls on the client side. You cannot achieve it entirely by controls on the server side. Because at the server, you can decide whether or not I serve up the information to you. But once it is available on the client, I have to extend my controls onto the client. Otherwise, the information is then completely unprotected. All right. So in order to achieve effective security in an information sharing context, we have to have controls on the client. That's just a given. And those controls would presumably be based on this trusted computing technology, because that's what the vendors are putting out. Okay. And certainly, we will see information sharing is a very big problem. And it includes retail digital rights management. So if I sell you some music, I want you to play it on your computer, but not for it to escape from your computer onto some file sharing network. Okay, so that's been a sort of major driver of this line of work, and people have sort of even equated trusted computing to retail DRM, but that's not scientifically a good way of thinking about it. And then, so let me just, it's bigger than digital rights management. We tried to sort of classify this information sharing problem. And if you think about it a little bit, you very soon realize that this is a really big thing. There are many, many different aspects to it. And I'm not going to go over these two slides. They are from this paper that is quoted here. So it's about 2004, 2-year-old paper. This was an attempt to try to classify this problem domain, but really, you just have to take it for granted. We don't have the time to kind of go through this space, but this is just too big a space to even. So it's like, you haven't even gotten an understanding of the first few elements, and you're trying to draw up the periodic table, and it's not going to happen. You need to be at a much more mature stage of your science and discipline to be able to do that. So how do we make progress in this area, given that it's sort of premature for us to try and characterize the space even semi-completely, let alone fully completely? So the approach we have taken is to look for some sweet spots, find some areas where, if we define the problem as saying, how do we apply trusted computing to information sharing, then maybe we can find an appropriate piece of information sharing that for which trusted computing is relevant. And maybe we can find usage control as a useful way of thinking about it, and the pi layers as a useful way of thinking about it. So we've taken a kind of pragmatic approach to this. Not trying to boil the ocean, but looking at a specific problem. Now, when you look at classical approaches to information sharing, certainly discretionary access control tried to solve this problem. It says, if I create a file, I am the owner, and I determine who can read the file. And yes, I determine not only can you read it, but can you provide the read access to other people and so on. And this is a well-known sort of aspect of discretionary access control. Unfortunately, it's a fundamentally broken idea, because once you can read the file, you have the capability to copy it, and maybe you don't have the ability to grant access to the original file, but to the copy you have complete control as to who can access it. So you can distribute the copy freely. So, this sort of copy problem sort of kills discretionary access control, and that's been well known. I'm not observing this as anything new. This was known back in 1971 when mandatory access control was invented to precisely address this weakness of discretionary access control. And it was very early recognized that the problem is not so much with the end human users, even if you trust them not to violate the discretionary access control intent. There are Trojan horses, there's malicious software that can do it without their knowledge or cooperation. And anyone who has a Windows machine today has lived with, if you thought Trojan horses are a figment of the imagination, you may want to examine your PC when you get back to your desk. We have to scan these things day and night to make sure they aren't infected, right? So the problem of malware is certainly known to the average consumer today. So, mandatory access control was supposed to solve this problem for us. However, mandatory access control can only do a coarse-grained kind of solution by slapping on top secret, secret, unclassified, confidential labels on information and controlling information flow at that level of granularity. And even there are all kinds of problems with covert channels and so on. So it's not that easy to do. And certainly it doesn't scale up. If you want to do this very fine-grained, you want the document to be accessible only by ad hoc collection of people rather than by everyone who is labeled top secret, you will get a real super explosion of security labels, and that's not friendly. And so their standard solution has been, you keep it for the big level stuff like top secret, secret, classified, confidential, and so on. And for the fine-grained stuff, you use DAC. But by the way, DAC does nothing for you. So, you haven't, it's kind of not really solving the problem.